Ignition sequence starts.
Good morning. Welcome to Mission Control Houston and the International Space Station Flight Control Room, where Flight Director Mary Lawrence and the Orbit 2 team of flight controllers are keeping tabs on all of the space station systems and working with the Expedition 58 crew members as they get everything in place for another station first. On top of their usual work with science experiments this week, Commander Oleg Kononenko and flight engineers Anne McLean and David St. Jacques have been busy getting everything in place for this weekend's expected arrival of the first commercial crew vehicle to launch to the station from an American launch pad.
Houston Station on Space to Ground.
Welcome to Space to Ground. I'm Kayla LaFrance. This week, astronauts aboard the station have been preparing for a special visitor. NASA and commercial crew provider SpaceX are getting ready for the March 2nd launch of the Demo 1 uncrewed test flight to the International Space Station. The SpaceX Crew Dragon spacecraft will launch on a Falcon 9 rocket from the historic launch complex 39A at NASA's Kennedy Space Center in Florida. This uncrewed test flight will be the first time a commercially built and operated American rocket and spacecraft designed for humans will launch to the International Space Station. Dragon will spend about 5 days attached to the space station until March 8th, when the spacecraft will return to Earth. Be sure to tune in to NASA TV on March 2nd to watch full coverage of the launch of the Falcon 9, starting at 2 a.m. Eastern. Then tune in again the following day, March 3rd, to watch the rendezvous and docking of the SpaceX Crew Dragon spacecraft to the International Space Station. That docking is scheduled at 6 a.m. Eastern. Station crew members spent time this week immersed in virtual reality as part of the Vection experiment. Vection, a Canadian science experiment, will assess how crew members judge distances and process their own movement while they are immersed in a virtual reality environment. This research hopes to determine how visual motion perception, perceived orientation, and the ability to estimate distances changes between Earth normal, 1G, and the microgravity environment. The knowledge gained through this study will help design safer methods of movement around the International Space Station, and it could also help future astronauts land small spacecrafts on lunar and planetary surfaces. This week's question comes from Grace Ritter 6, who wanted to know, how do astronauts keep clean in space? Since water does not flow in a zero-gravity environment, astronauts cannot wash their hands or bodies under a faucet like we do on Earth. This means that there are no sinks or showers on the space station. So to keep clean, the astronauts use wet towels and a little soap to wipe their bodies. When it comes time to wash their hair, astronauts will use a waterless shampoo. Keep sending in your questions using the hashtag #SpaceToGround. We'll see you next week.
This weekend's launch of the SpaceX Crew Dragon on its first test flight is a milestone for the commercial crew program's effort to open a new avenue for International Space Station crew members to get to their home on orbit. This flight will not have astronauts on board, but it will be a major step to getting these vehicles checked out and ready to join the fleet.
So we're going to have an orbital flight test, a test without the crew in it of each vehicle, and then we're going to have the first flight with crew in them to prove that these systems are ready to fly people to space.
These demonstration missions are important for astronaut safety because, the folks around here that I work with, we all ask ourselves, would we be comfortable flying our own family on board this vehicle? And the answer has to be yes. And so because of that, we need to make sure we test these as much as we can.
Since we're dealing sort of with a new generation of people who are putting human space vehicles together again, I think it's important to impress upon them every day that there is not a day where their attention can waver.
We can test them down here on Earth. We can put them in vacuum chambers and acoustic chambers and do thermal tests on them. But there's nothing like going up and putting them in the real environment.
That will give us a lot of insight on the vehicle performance, the functional systems, even the abort system will be active on that vehicle.
So that's why these initial test flights are so important, is because you need to see it's not just the hardware, it's also the software, it's the people, it's the procedures, it's the whole thing coming together.
Boeing's supposed to land on land, SpaceX is supposed to land in water. Those are two hugely different environments, so there's a little bit of interest in the survival equipment that's located in the spacecraft as well, where that's going to be, how that's going to work.
This is a really critical aspect of the NASA job, is to continue to have that dialogue with the contractors about, well, why did you do that? You know, why was that safer?
This is someone's family member, husband, wife, uncle, aunt. It's not an option to not be successful. We have to be successful.
Our Crew Dragon launch coverage on NASA TV and NASA.gov begins Saturday, March 2nd at 1 a.m. Houston time. That'll take us right through the targeted launch of the uncrewed Demo 1 flight at 1:49 a.m. Central. And then we'll be back at 4 a.m. Houston time with a post-launch news conference. We start live coverage of the rendezvous and docking of the Crew Dragon to the International Space Station on Sunday, March 3rd at 2:30 a.m. Central time. Docking is expected at 5 a.m. Undocking, deorbit, and splashdown are all on the schedule for next Friday morning, March 8th. And of course, all these times are subject to change. That's just the nature of the beast. Now, part of the science mission of the International Space Station is to take advantage of the weightless environment in low Earth orbit to do research on new technologies that can benefit future exploration, or life on Earth, or maybe both. For example, the station is now home to the Refabricator, a 3D printer that can make things and then recycle them and 3D print new things with the same plastic.
The inSPACE Refabricator. Presented by Science at NASA. While 3D printers are technology that many people are familiar with, there's one 250 miles above us on the International Space Station, or ISS, that's unlike anything currently found on Earth. It's known as the Refabricator, a hybrid 3D printer that can recycle its hard polymer plastic numerous times to make new items. About the size of a dorm room refrigerator, the device is controlled by operators on Earth who oversee its manufacturing via video cameras. Nikki Werkheiser, NASA's inSPACE manufacturing manager at Marshall Space Flight Center in Huntsville, Alabama, says, recyclers on Earth grind plastic pellets to create their products. But that grinding creates material shear, which prevents you from reusing that plastic again. It's no longer strong enough. For this technology demonstration, the company, Tethers Unlimited, developed a novel recycling process that doesn't require grinding, and that allows us to recycle the plastic multiple times. The ability to reuse the plastic over and over again is essential for long-term space exploration. Werkheiser says, we can replace a lot of the things we need when we're orbiting above Earth. We just have them delivered on a resupply mission. But when you're in deep space, you don't have that option. You have to have the ability to make all the parts you might need, and without having a large stockpile of extra materials. The Refabricator can even recycle plastic items not normally associated with Earthbound 3D printers. For instance, almost all of the materials that are delivered to the station are packed using foam or plastic bags. Both can be loaded into the Refabricator to deliver items such as a plastic syringe, an eating utensil, or a custom-made wrench. That ability limits the amount of backup materials you need to take with you on a long-range expedition. After all, in space, space is at a premium. The Refabricator's technology demonstration will be composed of 2 phases. During each phase, the Refabricator will perform 7 cycles of recycling and printing parts while on board the ISS. All of the items printed by the Refabricator will eventually be sent back to Earth for testing and analysis to determine the effects of repeated recycling on the material properties of the plastic. Werkheiser notes, I'm very excited about this technology both in space and back on Earth. I can envision a day where you go to the grocery store and drop your water bottles and plastic bags into a refabricator, and then select your new phone case or a kitchen gadget or the raw filament that you can use in your 3D printer at home. For more science from the International Space Station, go to www.nasa.gov/ISS-science. For more information about how the promise of future exploration is transforming today's technology, visit science.nasa.gov.
Being the hands in hands-on science is just a part of the job for the International Space Station crew members. The astronauts and cosmonauts also spend some of their time sharing the experience of being in space with us Earthlings. During the year of education on station, some of the astronauts worked on a series of demonstration videos to help students learn about key scientific concepts, as Mark Vande Hei did when he focused on Newton's third law of motion.
Welcome to the International Space Station. I'm NASA astronaut Mark Vande Hei. Today, we're going to talk about Newton's third law. How do you think it will hold up in microgravity?
For every action, there is an equal and opposite reaction. This means that in every interaction between two objects, there are a pair of opposite forces acting on each object at the same time. A force pair. You can see that there are many examples on Earth. In space, thrusters expel one way and the vehicle is steered in the opposite way.
Hello again. More basketball stunts that I can't do on the ground, at least not while getting this much hang time. All right, back to serious business. I've got a basketball right here. It's going to be object 1. I'm the second object. If object 2, myself, applies a force to object 1, then that same force will be applied, according to Newton's third law, by object 1 onto object 2. However, there's a big disparity in the mass. Object 1 is a very light mass object. Object 2, myself, is a larger mass object. So I'm going to try to make myself about the same shape as this ball. See how that works for us. And I'm going to apply that force. You saw that force applied to the ball made it accelerate quite a bit. It really didn't accelerate me much at all. Newton's third law again, but this time we're going to use two similarly massed objects. Joe and I have about the same mass, so Joe, get into a ball, I'll do the same. I'm going to face you this way so that I don't throw you into something you can't see. Now I'm going to get into a ball behind Joe, and I'm going to apply a force to him. Notice that when I applied a force to Joe, it accelerated Joe away from me, but I got accelerated away from him as well, because the force applied to Joe ended up being the same force that was applied to me. Now you've seen Newton's third law in space. Now test it out on Earth. See you next time.
Along with scientific research and promoting international cooperation and commercial participation in space, the International Space Station mission is designed to enable missions of the future, the ones that will take human explorers into deep space. The Flight Analogs project of NASA's Human Research Program contributes to the preparation for these missions by simulating the confinement and isolation of a ship in space to learn what it'll take to support crews on extremely long missions. The 5th Human Exploration Research Analog Campaign is underway right now here at the Johnson Space Center. Here's a look inside the habitat they're using so you can see what supports 4 volunteers during a 45-day-long test.
We can simulate what it is like to be in a spacecraft. So the isolation, the confinement, the controlled environment. The research investigations are aimed at answering some of the questions that we need to answer before we send people on those extremely long duration missions, such as to an asteroid or to Mars. It's probably about the size of, I'll say maybe a one-bedroom apartment that's not terribly luxurious. But on the other hand, it emulates what you might see in a spacecraft. A lot of the things that you have on the first floor are things like workstations. You know, some of the computer and some of the simulation devices are on the first floor. We have a lot of capabilities for performing different kinds of experiments. The second floor, it's kind of like your living room. There's a table that the crew members can sit at and eat their meals. All of our food right now is coming from the Johnson Space Center Food Lab, which means it's the same food that goes to the International Space Station. There's also a capability for them to play videos or to watch movies. We have a couple of exercise devices, a bicycle in particular, and then we also have some free weights. We find that a lot of our crew members will also do some calisthenics, some stretching, maybe some yoga. So there's a tiny little place for them to be able to do that. The final level, if you will, is really not a full story. It's really the sleep quarters. It's bigger than a pup tent. Each crew member has his or her own sleep quarters. It's actually very cozy, very comfortable. The hygiene module has a flushing toilet. We have a stand-up shower with hot and cold running water, and we also have a sink with hot and cold running water. The final element of the module is a very small module that is an airlock. And we do isolate or subdivide the crew such that 2 crew members will go into the airlock, and that is where they'll do their virtual reality EVAs from.
I'm excited for the challenge. I love a good challenge. I'm a professor at Grand Valley State University. I teach biology. I feel like I'm actually playing, it's a small role, but it's a real, tangible, important role in getting people to Mars. The first thing I saw about this was on a Facebook posting, and a couple of former Hera crew people had posted that they had just come out. I didn't think I would be selected, and I just kind of did it on a lark, and it worked out awesome. They are measuring us in more ways than I could have imagined. We've given a lot of biological samples of various types. They're measuring our heart rate, our brain waves. They're doing a tremendously large number of psychological tests on us.
This mission, the crew members are going to an asteroid. So while they are on their way to the asteroid, they are going to practice their flying skills once they get to the destination. They're also going to be conducting some virtual reality EVAs. So on the way there, they're also practicing those skills. We have the housekeeping tasks for them. We have maintenance types of tasks. A primary purpose for the mission controllers is really to ensure the safety and well-being of the crew members who are inside the Hera, to make sure that everything is going well. But it's really also to, as much as possible, to keep all of the scientific investigations happening as they're scheduled on time, to answer any kind of questions. We provide some input, a newspaper, if you will, electronically to the crew members in their, I'll call it their morning mail. Not allowing the internet access really does allow us to keep the crew members really engaged in the mission and not to be, concerned about things that are going on in the outside world. The one little luxury, if you will, that they have is approximately once a week, we schedule them for a private family conference. So a telephone call that is patched in on a private phone line. We do plan to keep the Hera operating for at least another 4 or 5 years. The 45-day missions, we're always going to be looking for qualified crew members to be able to come and join us and participate in the research studies.
The International Space Station has completed more than 20 years in space, helping us get ready for missions back to the moon and out into the solar system. Those are missions that are going to fly on the Orion spacecraft. Here's a look at the current state of work as teams across America and in Europe develop and build the systems that will carry us to those future destinations. The Orion program is developing the vehicles that will take humans out into space. SpaceX and Boeing are building the vehicles that will take crews to the International Space Station, where we'll learn about how to live in space on those future missions. Here's a look at a feature that'll help us see what those future missions of discovery will look like.
From the Kennedy Space Center in Florida at T-minus 3 hours and holding.
It is great to be in Florida today. The rocket is ready to go fly. The team is ready to go fly.
Not only for for our expanded knowledge of the universe, but for the improvements you have contributed to on Earth. Have an excellent mission and Godspeed.
Crew ingress and work at this time.
Amen. Flight crew OTC, close and lock your visors and initiate O2 flow.
T-minus 10, 9, 8, 7, 6. All the engines up and burning. 2, 1, 0, and lift off.
The dawn of Orion and a new era of American space exploration.
Those missions coming in the future. In the near-term future, this weekend, the Crew Dragon has its first ever test flight to the International Space Station. Be sure to check in with NASA TV and NASA.gov on Saturday, March 2nd, 1 a.m. Central Time. We'll start our launch coverage. Launch coming at 1:49 a.m. on Saturday. Rendezvous and docking coverage of the Crew Dragon to the space station starts at 2:30 a.m. Central Time on Sunday, March 3rd. If you'd like another look at any of the features that we showed you today, be sure to check us out on YouTube and on Facebook. And while you're there, take a look around at some of the other cool stuff that you can find about NASA and America's human spaceflight program. And while you're out there on the internet anyway, check out Houston, We Have a Podcast. That's folks here at NASA talking about their work in all aspects of space exploration. We post new episodes on Fridays, and today, Gary Jordan learns about a NASA program to help develop the agency's leaders of tomorrow from among the early career employees who are here today. Go to nasa.gov/podcasts. You can find today's episode. In fact, you can find all of the Houston We Have a Podcast episodes, and, yes, there's more, the full library of all the NASA podcasts. Right there at nasa.gov/podcasts. You can listen to any of them as well on Apple Podcasts, Google Podcasts, and SoundCloud. This is Mission Control, Houston.